So Steve, what about if I have a database, a relational database, a SQL database? How do I actually build for the cloud with some sort of relational backend?
Yeah, I love that question. And the answer to that is there's a lot of different options for the cloud. And this shows kind of the spectrum. If you take a quick look at the slide, you're going to see the spectrum going everywhere from SQL Server, which, by the way, we can host SQL Server in IaaS, all the way through to Azure SQL, which is where we would be doing those relational work. And I want to just quick mention, we've got things like DocumentDB, HBase on Azure Insight, on HD Insight, Redis Cache, Azure Tables, which we've already mentioned. We have non-relational as well, but let's come back to that later, because your question, I think, is very appropriate. How do we deal with relational in the cloud? And the answer to that can be one of two things. Take your SQL Server and install it in the cloud. Boy, that seems like you're sure doing something a little bit odd when you do that, because you've got access to SQLDB, which is the managed service, the platform as a service that you can use instead. But there are cases for both of them in this case. Let's talk SQL Server. Step back for a moment. SQL Server is an industry leader across the board. Quick look at the slide. I'll just nail some of the highlights. OLTP, it's the most secure database. It's got the highest performing data warehouse. It provides end-to-end mobile BI on any device through some neat reporting stuff they've built in. Advanced analytics for in-database stuff, including running R. It'll run, which is becoming a standard statistical language. R can be run right inside of SQL Server. So why do we care about SQL Server? For these reasons. But let's make the assumption you're ready to go with a relational data store. Then where do you go? We go to Azure SQL DB. And we do that because it provides us with this underlying SQL database that we simply can use as a service. And what we can do, we can pay for it in a number of ways. If we want just one SQL DB, we can just pay for that. If we want 100 SQL DBs, but they're going to share some of their compute power, we can create an elastic database pool and add them all into that, where we can pay one kind of smaller, potentially, bucket. But the idea behind Azure SQL DB is it's managed for you. And there's some things that you can do that you just really hard to do with an on-premises SQL server. If you look at the slide, here's a few of them. It learns and adapts for you. It figures out some of the ways that it can optimize itself. And we'll talk about this more later. It scales on the fly. We can walk in and simply move it from, we're starting to get a bigger load, we move it from an S1 to an S3, for instance, or move it into a premium store. Redefines multi-tenancy. It just blows away the way we've thought about multi-tenancy in the past. You may have had to go in and say, hey, we want a multi-tenant application for our website, and then figure out how to divvy things up in the back end so that your single database doesn't step on each other. No longer. Every customer, every tenant can have their own SQL database, but you can group it under this one giant umbrella, that elastic DB that you're calling. Everyone gets completely independent data sets, no sharing, no risk of sharing, but you get all of the benefits of paying for one unified thing. And when one person's not using it, other people can use it at the full capability. It works in your environment regardless of where you are. If you're on premises, you can push up to Azure SQL DB. And it secures and protects itself and has some analytics behind that. And I want to dump into a little bit of those later. But let's take a look at why we might use it. It's built for app devs. It gives us more time to innovate. You don't have to maintain the SQL database. It adapts to optimize its own performance. It'll query you and tell you, hey, do you want to do this optimization? And you can say yes. Here's a few things that you get just out of the box. There's threat and anomaly detection. You might be using your database at a particular cadence and usage, and then all of a sudden, wham, it just ratchets way up without a corresponding change to some other behaviors. That would be an anomaly. And by understanding the anomalies, we can start to understand when there are threats that are attacking our production system. So we've got this idea of understanding what our servers can do and what we can understand, and we can get alerts, we can look at logs, we get this built-in behavioral analysis of how people are using our SQL Server, how is it being used, and then alerting us if something else comes out of that, if we have kind of unusual patterns. Self-tuning performance. I've talked about this already as well, but this dives into a little bit more deeply. If you take a quick look at the slide, it can help us manage our indexes, tailor it to whatever workload that's actually running it. It's a recommendation engine that, by the way, one other thing, that recommendation engine uses the machine learning capabilities of Azure behind the scenes. So indirectly, you're using some cool platform as a service stuff, which is the machine learning capabilities also baked into Azure.
I want to jump in with a story there, Steve. We did some work for a customer where we helped them develop a web application, and it used SQL DB in Azure for the back end. And even now, after months of finishing that project with their customer, they've been running their system for a couple of months, and every now and then I still get an email from Azure to say, hey, you may want to look at this particular query. There's an index here that could improve some performance. So it's great seeing that feedback come as the system is being used and as the system is evolving, which a lot of our applications do. We design them with a particular design at first, but then as the application evolves and as we grow the feature set, we get different load than what we expected initially. And so it's great that the tuning advisor is continuously monitoring what's happening in our database and suggesting these performance improvements for us.
I love that. And I love it because I am not necessarily a dyed-in-the-wool SQL expert, right? I can do some SQL queries, I can do some of these things, but it's making indexing recommendations that I would never come up with on my own. So, actionable recommendations, these come, they give you some recommendations as to what to do for both performance and security issues. And it's got this administration and data protection baked in. So one of the problems with any database work is you've got to make sure that, one, it's working for you, right? You've got to make sure that it's failover. So you have to have your Quorum server and your two databases and everything else working together to make sure that you can fail over into the other SQL Server. They do that for you automatically in Azure. That's baked into all of the tiers. And if you go up to a premium tier, you get even more performance enhancements and more backups. Oh, that's important to also mention. You need to back up your database, not just for failure, but in case someone, you get Johnny drop tables in your thing and somebody drops all the tables by accident in your database, you need to be able to come back in and restore that to a prior version. There's snapshots taken periodically, and they're stored for a certain amount of time depending on whether you're on a standard or a premium data tier. Really amazing stuff, and it's just kind of baked in. And if you want to scale it on the fly, it really is just scaling it on the fly. You move it from a standard S1 to a standard S2 or 3, and up it goes. You can move it to a P6 if you want to jack it way up and get a lot of performance. And it does that for you on the fly. And you only then pay for what you're using. So why do we want to use PAS for data stores? Why that SQL DB? A lot of different reasons. If you're doing SQL, here are all the things you need to maintain. Even if you're doing it in Azure on IaaS, you still have to maintain all these things. But look what you have to do when you're developing your code against SQL DB. Nothing but your app optimization. And this, I believe, is important. It comes back to the very first discussions we had about the extraordinarily high productivity gains that developers get when they work against something like the platform as a services that are being offered on the Azure platform. App optimization, that's all you care about, and that means it takes off your mind all these other things that you formerly had to worry about. We get 406% ROI from another study that some external organizations did for Microsoft. So what do? We let Microsoft handle all of those sorts of things, and that's why we might use PAS for data stores.